Hi everybody. Um, so I'm not using the normal uh, program to record because it's a tough one to write a lot of stuff with, and this is going to require a good bit of writing. So I want to try and talk about the standard normal curve or the standard normal distribution, z-scores, how it relates to normal CDF and invnorm. And it's going to be a little scattered, but I'm going to try and connect them as best as I can. So to begin with, you guys are familiar with the empirical rule. We've talked about it in the past, but let me refresh your memory. The mean in the z-score world, or the standard normal distribution, is 0. You can take any normal curve and using the z-score formula, and to remind you, z is equal to x minus mu divided by sigma. And what that is it's a transformation. So it'll take whatever mean you're dealing with and it will slide it down the number line. And so it's sitting centered at 0. And then the other piece of it is that no matter what your standard deviation is, it slides it down as well, and you are at 1 and negative 1. So you are 1 standard deviation to the right, you are 1 standard deviation to the left. And then you are at 2 and then negative 2. 2 standard deviations to the right, 2 standard deviations to the left. Then we're at 3 and then at negative 3. And it keeps going, actually. Goes off to negative infinity and positive infinity. And the areas, the percentages, based on the empirical rule, which please understand are very close approximates, are 34%, 34%, 13.5%, 13.5%. And then your author doesn't use this, but it goes 2.35 and then 0.15%, and then 2.35 and then 0.15%. Now, if you actually do the normal CDF, this will be about 2.14, and that's a little bit higher. But what's going on is from 3 off to infinity, there's only 0.15% of a chance of landing a value beyond 3. Same less than negative 3. So in our world of statistics, and part of the reason that your author stopped at negative 2 and 2 is that beyond 2 and negative 2, standard deviations away from the mean, it's considered outliers. Another way to talk about it is that if the probability of whatever event you're talking about is less than 0.05, that's considered an unusual event. And the reason is that if you add these pieces up, you get 5%. So if it's less than, you're out in these tails, okay? Now let me erase that little piece. All right. So just real quick, if we're talking about IQ, and the mean of IQ is 100, and the standard deviation on this one IQ test is 15, then the z-score for 100 is 0. The z-score for 115 is 1. The z-score for 85 is negative 1. Let me just demonstrate real quick. 85, remember it's x minus the mean divided by the standard deviation. So you've got negative 15 over 15, which is negative 1. Okay. Now, suppose we're dealing with something else. Heights of, I gotta make sure I have the right data in my head. Heights of males. I think it's 58, or is it, no, it's 68. Yeah, it's 68. I believe it's 68 inches is the average height of a male. 65 inches is the average height of a female. And then the standard deviation for men is actually less than the standard deviation for women. You get more variability in height of women than you do in height of men. And so I'm just going to be kind to ourselves, and I don't remember exactly what the number is, but we're just going to say it's 2. Okay. So the z-score for 68 is 0. The z-score for 70 is 1. The z-score for 66 is -1, assuming those are right. Okay. But don't get hung up on whether they're right or not. Just any mean. Like we can just say the mean is 40, and then the standard deviation is 1. Well, here's 40, here's 41, here's 42, and the z-scores go with it. Now, let's build this a little bit farther and now start talking about probability. And the probability are these percentages, okay? And the normal CDF here in your calculator is going to be able to get it so that we don't have to only land on the 1, 0, and the 2 and the 3. All right, so pretend that the mean is 50 and the standard deviation is 5. All right. And we would like to find the probability that our x value is going to be greater than 58. All right. There's 2 ways to approach this. You can approach this in raw data land, or you can approach this in z-score land. Let me first do it in z-score land, then I'll show you how to do it in raw data land. So first we need the z-score for 58. 58 minus 55 divided by 5. Ah, sorry, I lied. 58 minus 50 divided by 5. So we have 8 over 5, which is 1 3/5, which is 1.6. So our z-score is 1.6. We're landing somewhere in that area, okay? Now, when I change to z-score land, I would write it as the probability that my z is greater than 1.6. All right, now, 2 ways to do this. Either way, you're going to hit the second key and then find the vars key, and you're going to see normal CDF. If you have a more modern version of the TI-84, it's going to say, right below it, lower, then upper, then mean, then standard deviation. And whatever your lower is, if you're in raw data land, and I'm abbreviating it normal CDF, your lower would be, if you're in raw data land, 58. We'd write 58 here on the lower. The upper, well, we don't have an infinity button. We should, but we don't. So we just need a really, really large number. So I'm going to put 10,000, okay? So up here, it's going to say 10,000. Now the mean, because we're in raw data land, will be 50, and then the standard deviation will be 5. And if you're typing it out this way, like you would if you had an old 83, it'll say 50 and then 5. Now just a couple of comments. Modern 84 is going to have it look like this. If you have an older 84, it's just going to say normal CDF, and it's just going to have a comma. So you've got to go lower, upper, mean, standard deviation. Lower, upper, mean, standard deviation. Now, if you, and part of the reason I show this z-score conversion is when we start doing hypothesis testing, it's helpful to have it. Okay. Now, if I did it in z-score land, normal CDF. Now remember, in z-score land, the mean is 0, and the standard deviation is 1. So our lower begins with 1.6, our upper, hold on. I don't know why it cut out on me. Sorry, folks. Sorry. So our upper is going to be, again, infinity, but we use 10,000. And then our mean is 0, and our standard deviation is 1. Now let me punch that onto my calculator quick. So second vars, normal CDF. Now you'll see mine, it just has the normal CDF. It doesn't have the lower, the upper, and so forth. So 1.6, 10,000, 0, and then 1. And I get a probability of 0.05. It's 0.0547. All right. And if you do it this way, you'll get the same result. All right. Now, I'll make one more comment here, and then I'm going to have to cut this off because I have a limit to how long I can make the videos for YouTube. And then I'll pick up again in a bit. So, this comment here is that this is not a percentile. And the reason it is not a percentile is that the area is off to the right. It needs to go off to the left, to negative infinity. So if I changed this way, and I made it less than and less than, and what would have to happen here is that these would have to flip. So you'd have 10,000, and it would be negative 10,000. 58, and here would be negative 10,000 to 1.6. And if you did that, you would get 0.94, but this would be a percentile because then we're talking about it going off to the left. And the reason that's significant is invnorm operates in percentile. And let me show you what I mean. So if I do invnorm 0.94, and if you're looking at the older version, which mine will say, it'll say invnorm, and I just type in the 0.94. In the more modern version, it'll say area, and you give it 0.94. It'll say the mean, tell it 0, and the standard deviation, tell it 1. What you're going to get, and because we're cutting off a bit of a decimal, we're going to get something that is about 1.6. So it works backwards. So the inverse norm accumulates the area, and it says, oh, I'm at 94% of the area. What's my z-score? And it kicks out the z-score. All right, I got to pause the recording there. All right, or stop the recording there. Okay, everybody. Have a good one, and I will make another video tomorrow.